Today's video will define a unit test. Hello, I'm James Helfrich. There are four types of tests. There are acceptance tests, there are system tests, there are integration tests, and finally there are unit tests. This video will define a unit test as well as show how to use them to provide quality assurances in our software. So first of all, let's talk about different types of testing. Now, there is acceptance testing, and this determines whether a given application or program is fit for use. The purpose is not to find bugs, but to see if it's finished. Next, we have system testing. System testing's purpose is to figure out the bugs in a system. And when we're finished with system testing, we found all the available bugs, then we can go on to acceptance testing. Now, notice that system testing is black box testing. In other words, I do not look at the internals of the system. I don't even know what kind of technology it's built on. I'm just looking at the publicly available inputs and the publicly available outputs. Then we have integration testing, and this is to take functions and classes within the program and to see how they interact with each other. When I'm completed all my integration testing, then I'm able to do system testing, and then of course on to acceptance testing. And finally, we have unit testing. Unit testing is looking at one individual function or class or method independent of the rest of the program. And once those individual functions, methods, or classes have been unit tested, then I can go on to integration testing and see how they interact with each other. Then I can go to system testing and to see how the whole system works. And then finally, I can see if it's fit for use. Now, it's important to realize that acceptance testing and system testing are not done by developers, but rather by quality assurance engineers. These are specialists who are very good at generating original test cases, be able to find the target audience, do acceptance testing, like beta testing and things like that, and also writing external automation. This is a different skill set than a typical developer has. Developers, on the other hand, or software development engineers, we perform integration testing and unit testing. This code is written into the code base. It has access to the actual code itself. It verifies that the test passed with asserts. So it's done a different way than system testing and acceptance testing. So a unit test is a white box developer-written automation used to validate a single function, method, or class in isolation of the rest of the program. So that's the definition of a unit test. So let's break that down. First of all, it's a white box. The unit test has access to the internal workings of the code under test. This usually means the unit test class is a friend to the class under test. So this means that if I'm going to write a unit test for a class, then that unit test is going to have access to the private member variables and private methods of that class, so I can exercise things precisely. So unit tests are developer written. This means that the software development engineer who wrote the code will also write the test. The two pieces of software, the test and the code, are written at the same time. In fact, usually we do the test first. We write the unit test. We run it to make sure that it fails, and it should fail because the code's not been written yet. Then we write the code and then run the test again, and now the test should pass. And so these two happen usually within a couple minutes of each other. Now, unit test is automation. This means it automatically runs. We don't manually test it. We just hit run, and then boom, all the tests pass. Usually all the unit tests are executed just before the normal code of the program. In other words, we hit run, all the unit tests pass, and then the program continues as expected. And this gives a programmer assurances that the base level functionality is met long before we actually exercise the code. And finally, it's a single item. A unit test is designed to exercise a single test case for a single method or function. The goal is to isolate the method or function from the rest of the program. And the reason for this is because if the unit test fails, we know precisely where the problem is. We can narrow it down to just one function or method, and usually within just one or two lines of code. Now, if we did an integration test where many functions and methods were being executed, then it's very difficult to tell exactly where the problem originated from. So a unit test makes it much easier to find bugs, and that's why they're our first line of defense. Let's take a look at a specific unit test. Unit tests are collected in a test class. In this case, the test class is called test collection. Test because it's a unit test, and collection because that's what I'm trying to exercise. The class name usually bears the name of the class under test, as it does in this case. Each unit test is a method in the test class. It is given a name indicating a method under test, which is append in this case, as well as the test case being fulfilled. In other words, I'm going to test appending to already filled collection. Now, a unit test has four parts: setup, exercise, verify, and teardown. And the setup phase is usually non-trivial, usually more than one line of code. The exercise is usually one line of code. The verify is filled with asserts, and the teardown removes anything that was allocated as necessary. So the setup directly sets the member variables of the class under test. This is true even if the memory variables are private. The subject has three member variables: array, size, and capacity. But the test class has access to the class under test's member variables through the friend process. So here the setup phase is not going to depend on the constructor working as expected. It will explicitly set the member variables. In this case, we'll allocate the array, set the 5 values for the array 0, 1, 2, 3, 4, set the size, and set the capacity. I'm also going to set the variable for the input, which is going to be the parameter I pass into it. So all this is set explicitly. I'm not relying upon any other code to make this work. So the exercise step is just one line of code. It calls the method under test, no more and no less. The verify step consists of a collection of asserts. In most cases, the asserts report errors without stopping the action. In other words, the traditional assert will halt the program as soon as it's been fired, but usually with unit tests, we want to have all the errors presented at once. Now notice there's no code being executed here. I'm not using any getters or anything like that. I'm simply going to access the member variables to verify is what I expect. And finally, the teardown step returns the program to the state before the test was run. In many cases, the teardown step is skipped in a unit test, and that happens when there's no allocation being done or networks being established or anything else. We can learn more about the unit tests in the unit test chapter of the software design textbook.